Hello time travelers. Today I'm going to be building the Two Kings boost, which is a clone of the Analogman King of Tone pedal. This is a kit that you can get relatively inexpensive on Stewmac.com, TOS. It's a lot cheaper than trying to get one of these used on Reverb or eBay or something, because there's a huge waiting list to get one brand new from Analogman. This is my look of disapproval. Alright, a quick message from me editing in the future. This is one of my longer videos due to the number of components that go into the board. And don't let it be daunting. The pedal sounds amazing. This pedal has inspired me to practice every day. And I practice on my guitar almost every day for the past couple of weeks since I filmed a video building this thing. In the video, I didn't record putting in every single tiny little thing, but I show an example of each thing. I show whenever something seems to be particularly difficult or I had to figure something out. But make sure you have the instructions available from Stewmac before you build this thing, or if you're doing another pedal and using this as an example, have the PDF or whatever they have available for you and read that while you're watching along with the video. Also, I have timestamps so you can go to whichever section you want to see how to do a particular thing. Oh, and this whole time, if you hear another voice in the background, that's my son upstairs. He's live streaming. Sorry. Just deal with it. It's not like his voice overrides my voice, and he's on my channel all the time. So he's good people. Come on. In the box, you got too good of instructions, in my opinion. They could have just done a printout like they've done with their previous pedals on their site. So stickers, I actually appreciate that, so I don't have to figure out how I'm going to label the controls. PCB, the back cover, a few bags of components. Front cover, I opted for the white painted one in case I wanted to just leave it, but I'm actually thinking of painting it. And some screws. Now here's the page in the instruction about diodes, and I want to make a note about that before I start building this thing. Here you see the 1N914 and the 1N4001, and I'm going to be replacing the ones on one side, which is this side probably, with the ones that Analogman actually uses, MA856 and 1S1588. Let me see what I got. So I've already got them. BA282s came in the mail yesterday. It's just what I'm going to use instead of the MA856 because those are extinct. Like, they died out like the dinosaurs. My first set of BA282s had less than I thought it had. I didn't read the item description on the page very well. Interesting how some are green and some are reddish, whatever. Here's my 1S588s. Oh, those are blue and red. Interesting. The reason why I'm doing one side and the other that way is so that I have the right side sound like the Analogman King of Tone with the more vintage sounding diodes and the left side sounding modern. There's another YouTuber that did that. Can't think of his name right now. Text on the screen when I find it again. Well, here's some of the pages with resistors. Another thing I'm going to try to figure out how to do is find the signal resistors and use these carbon film resistors instead of the metallic film whatevers. Metallic film whatevers are more efficient and more stable, but if you want a vintage tone, you have to look for these. I got a whole giant pack, but if you just replace them all, the whole pedal will be unstable. So if you find resistors that control power delivery, leave those with the more modern blue colored ones. This is all optional. Anybody watching this is all optional. This kit comes with all the resistors you need to make a fully functional pedal. So if you're watching this and you're not familiar with some of the things, make sure you read the first few pages. You got the resistors and other components you want to be able to identify later when you're putting stuff together. I also recommend you go and you get you one of these if you're going to be doing more than just this. If this is the only thing you're doing, you might be able to get away with a pair of scissors, but you have to be really, really careful with using scissors. These have the right sizes for each wire. Step 1 talks about how to do soldering. If you don't know how to do soldering, read that and also watch this video all the way through before you do any soldering yourself. And now step 2 is already talking about diodes. I just have to figure out which way is which, so that I know the one side is using the vintage and the other side is using the modern. And it says it uses a breakout board, so I'm going to break it out, maybe. Where's my knife? Got this from Stewmac too. I've been using this for years. It's just any pen knife, really. Just a little bit of cutting. Hopefully it'll let me pop it out. It says use a side cutter. Is this a side cutter? Does this count? Can't even get in there. So how do people get this out? Maybe with a box cutter? I don't have that one of those down here. If you have a Dremel with a saw on it, it'll work. Well, just a little bit of scraping with this and then twisting it and it popped out. Skipping ahead to the trim pots, we can see that the one on the left controls the right side foot switch and the one on the right controls the left side foot switch. So I'm assuming that's going to be the same for the diodes. The 1N4001 is that one. It's like orange with 2 blue stripes. Makes that easy to see, and they've only got 4 of them. 1, 2, 3, 4. Now I only need 2 of them. Now I found a pack of 8, and they look like that. So I'm saying these are the 1N914, I guess. Yeah, in my case, I'm only going to need 4 of those. But if you're not using the more vintage diodes, go ahead and get them already. Now all you got to do is bend them around like this and put them the same orientation as the drawing. Also on the PCB, there's a little line that matches up with the line on there. Right is left and left is right because it gets flipped over. So I want the modern ones on the right. Underneath, can't really see it, but I'm spreading the legs out a little bit to make it a little more snug so when I flip it, they don't fall out. Now check this out. Hold all these down with your finger and flip it over and bend them out like that. They don't have to be way out, but now I can do this. I have this really, really cheap soldering iron that I got off of Amazon that I could set the temperature to, and 650 is a good number. I don't know, I think I was working on something else and had to turn it up. Turn down fasters. I don't have all day. All right, that's good. Everything is great in this kit that came with this except for the solder. So get you some good 6337 is what I recommend. You can also use 6040, but it has to be a good brand with lots of good, come on brain, think. Reviews. So the solder that came with this was crap, but it had great flux, great solder sucker, everything else, and a bunch of really tiny tips. And the most important thing is do not go into this with a weller with a big tip because you're gonna burn it out and break it. You might have to go through a couple kits before you learn how to control that big thing. This is a lot easier to work with and it comes with a tiny tip by default. That's all you need. It's a tiny little drop and you want it to have like a Hershey's Kiss shape once it's done. I'm just gonna go ahead and put some solder on a bunch of these and then come back with some heat and make them have that Hershey Kiss shape. Now, after you do it, you might notice that some of them have less solder than others, like that one right there. Just go ahead and give it a little bit more. Oops. Now I messed up and I've bridged them, but that's not the end of the world. Here's a solder sucker that came with my solder set. Just go like that to where this part's compressed and be ready to press this button and make sure that end isn't clogged. You can unclog it with a knife. Heat up the solder. Pull away the soldering iron and quickly put this close and hit the button. And it sucks it up. Then take that naughty solder that was messing everything up and use your brass pad to clean it. This is sold separately. Any from eBay or Amazon should work fine. Now I'm just touching them up to give them the right shape. There, I pulled the extra off of that one. And by the way, this is off camera, but I'm always putting the soldering iron back down on this thing like that. Now get your side cutters and you just want to cut all these off. I wonder if you can see this, but I have to cut some more off because those are kind of hanging over and are stabby, but I'm inspecting it first. Yeah, looks good. Now I'm just going like this, getting really close. 1N4001 is ISI 588. I just need 2 ISI 588s. Interesting, the ISI 588 looks exactly like the 1N4001. Whatever, bro. And instead of the 1N914, for these 4, I'm going to use the BA282s. Funny again. They look just like the other ones. Well, almost. Okay, now inspecting it, I have the modern ones on that side, the vintage ones on that side. And they actually look exactly, well, not exactly, a little different. Whatever. Next page. Step 3 is the resistors. In this case, it tells you how to tell which ones they are by the color coding. And it also helps to have a voltmeter. Oh, they got a voltmeter there. But I'm kind of going to skip ahead and try to figure out where the power comes from, because those are the resistors I want to do first. These probably go to the pots, which are variable resistors. Nope. The knobs, or the pots, get soldered into there. There's a power. Where does it go? All right, Stewmac, this is a little confusing. You've got the battery positive and negative. Okay. And you're showing this. But where on the PCB does it go? You're not showing that. Right here, plus and minus. We got in and ground and out. That's for the signal. And then a plus and minus is there in the middle. Okay. All right. A little bit about resistors. I'm not going to talk for a really long time about them. But here's an example of one. And I'm looking at this, and it looks like brown, brown, black, black, brown. Maybe? Brown, brown, black, black, brown. So it goes this way. So that says it's 1000. This is how you test it. So you get any voltmeter, this ohms test on it. You pick a number that's bigger than what you want to test. Since I want to test a 1K, which is 1000, put it on the 2000. Sit still, resistor, while I check you. So that's 1000 about. See? Analyzing this circuit, it looks like the power comes in and it hits this operational amplifier, which has the ability to do resistance within itself. And coming down over here goes down to that, whatever that is, and there's a resistor right there. And these are connected to each other. So those are going to be your power, and those are 4.7K resistors. Yellow, violet, black, brown, brown. Yellow, violet, black, brown, brown. That might be it. There's only 2 of them. You can tell I'm not an expert. I still built a couple pedals. Here we go. There's a 4.7. Turn down to 20K. It'll say 4.7 watch. No? I'm pretty sure this is it. Because it says yellow, violet, black. That's 47K. Oh, I don't want to mix up the 47K with the 4.7. Yellow, violet, black, brown, brown versus yellow, violet, black, red, brown. This is yellow, violet, black, red, brown. This is a 47K. Oh, big mess of components. Is it this one? That says 4.7. Toss. In this kit, it comes with these 3 diodes as well, and they actually say 5817 on them. That's helpful. I forgot to put these in earlier. Sorry. Let's just go whatever, put them in. All right, I finished step 3 to install this page worth of resistors. Still have to do this page. A couple of things of note. The PCB does have the value of each resistor on it, which helps a ton. The ones for the 6.8K, sorry, it's covered right now, but they say 6K8. So that basically means 6,000 plus 800. My little pack of resistors that are carbon film did not have a 6.8, so I went ahead and used the electrolytic, or whatever they are, aluminum film. Not electrolytic, I'm thinking of capacitors. Duh. And then when I was doing the 1K, I forgot to use a carbon film, but I'm like, oh well. Now, there's an important thing of note on the second page of resistors. It says install 2 more resistors, either 1K, which is stock Analogman, or 100K. For higher gain, install the 2 100K resistors. Gain means power. So when you have a volume control, what it's really doing is taking 100% signal and turning it down. Gain is different. It adds electricity to the signal to make the output higher. So if you got that basic fundamental down in your brain and you know how much gain you want to have, well, if you want more gain than a stock Analogman, you're going to want to use the 100K. That's going to be good for like metal. You know, I'm not into that genre, so I'm going to use the 100K. And since its gain is an electrical signal, not an audio signal, well, it adds You know what? I'm going to go ahead and use the metal film on this side and grab a 1K carbon film resistor for the other side. And switching to page 3, well, step 3, page 18, looks like the rest of the resistors. I don't have my small screwdriver set. It's called iFixit. It's in the other room because I was using it for something else, but let's see if this knife can turn these to 12 o'clock. Nope. Oh, there we go. That's sort of 12 o'clock. And that kind of already looks like 12 o'clock. They sit in there crooked, but it doesn't matter as long as I get good solid solder joints. Here's another point where some people might choose to modify it. I've seen clone DIY kits and otherwise, or even just regular Analogman pedals with little toggle switches on the outside to replace this. Reading what it says here, the dip switch you're about to install allows the user to customize tone when its 4 switches are arranged in different combinations. The 4 switches engage blah 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 blah. But it gets to the point. You can choose between clean boost, overdrive, and distortion for each side. So if you wanted, for example, the right side, which is the first one, to be a clean boost into an overdrive pedal, then imagine giving your overdrive pedal more gain at the touch of a button with your foot. Same tone, just more of it. Well, more tone. It would change the tone in some cases. 1 and 2, it says right here that dip switches 1 and 2 are for the right side of the pedal. 3 or 4 are on the left. And they say when we reach step 23, they'll explain how to adjust it and fine tune the dip switches and the trim pots. That goes right in there pretty easily. So you might be asking, how would I mod this with switches? And it looks like you need just a simple switch that just has the 2 metal prongs where you flip it up to be on and down to be off. Because if I take the voltmeter and put it on continuity, what continuity does is test if it can touch itself and it beeps. Now these are all down and there's nothing. So if I turn dip switch 1 up like that, now it's connected. Okay? So you would just need 4 of those. I'm holding the dip switches in position with my finger. Ow, burn myself. Okay, to the mouth it goes. All right, I got 2 of them to hold it together. I personally would love to have switches on the outside of my pedal, but I would also like labels. And where would I put the labels? It'd be too crowded. Now the real question is, would I even use distortion? No, I'm not a fan of distortion. I'm more of a fan of overdrive. Me personally, would I use boost? No. I do like boost. I use boost sometimes, but the boost for me, I like it earlier in the pedal chain, not all the way up on my drive. So I might just try it with the settings at overdrive first before I decide if I want to mod that and put switches. Now it looks like we're doing op amps. This is another thing you can modify by doing faster or slower ones. And I did that in a previous video. You can check it out by clicking the card up here. Boop. All right, here's the sockets. There's one coming out of the bag. LED, get out of here. You're not in this scene. Go back in there. 2 and 3. And this one I got to straighten out the legs very carefully. And these are the sockets that they fit into so that you don't damage these, because if you damage these, they're super hard to get out. But you got to keep in mind there's a little half circle right there, and you also have this half circle on the socket, so you have to point that in the right direction. And then when you put this in there, that little circle is on the same side as the half circle on the socket. These are nice. These are at least nicer than the last pedal I did that used these, because they got little angles in the legs so they stay in there. I'm less likely to burn myself with a soldering iron doing my awkward maneuvers. And the great thing is that if you decide to modify the op amps, you don't have to take these sockets out. They stay in here forever. Make sure you put them in the right way. I really want to finish because I got keto ice cream upstairs and I hear my son running all over the kitchen. He must be starting on his already. Dang it. Come here, solder sucker. You're in this scene. You compress it, you inspect it, you heat the work, get the big clump of solder all wet, and just do that. Don't worry, I'll come back and I'll finish this video. Did you find the cones? I got cones for the ice cream.
I thought you were talking about like traffic cones or something.
Oh, that's right. He has to put all his streaming equipment away. That's why he's walking back and forth. Duh. Finish these ICs so you can help your son. Alright. This middle one is the TC1044 SCPA. Not that one. Not that one. Well, these are 4580D. So just put those together, and this other one that doesn't match, that must be it. I can barely see anything on it. Can you see that? Max 1044. That must be it, because that says 1044. Now again, I remember seeing a little half circle on that side, and a half circle is right there. Legs look straight, except these can go in a little bit. So I made sure the legs were straight first. If you feel like replacing or modding it, you just research the model number, see what it does. You don't have to get super geeky. Find some thread where people are talking about it and comparing it and asking questions. And that's how I modded this other guitar pedal I built. Made it sound cleaner. And that's in there. When you buy these on eBay, they typically put them in foam, little pieces of foam so the legs aren't bent. Stewmac, that would be helpful if you did that. Ugh. All right, that wraps it up for this part of the video, and I'll be right back. All right, now it's time to work on the capacitors. I'm here on part 2, day 2, whatever. It's all the same video, who cares? Electrolytic capacitors, which are the tube-shaped kinds, have a little white line on the side, and that white line means it's the negative. So electricity comes in the positive side and goes out the negative side. For example, you've got one right here that's got a plus on that side and a minus on that side. Well, it doesn't say minus, but you know what I mean, and a plus and a minus. But the other capacitors, you don't have to worry about which way you put them in. This weird tape, it doesn't want to let go. I'm just cutting it off. Screw this. It's all biodegradable. And it says they go next to the little holes for the pots. So negative on the negative side, positive on the positive side. I've never seen red caps before. If anybody watching this video knows what's up with these red caps, tell me. What if there was cap color tone? That would be ridiculous. You didn't get to see this much earlier in the video, but I've been putting the tip of the soldering iron in this flux and then scraping it off in between, and it's been making it easier to get clean solder joints. This flux came with this soldering iron, and it's really good. It's some of the better flux I've had. And these are the other capacitors, and I'm keeping them separated because these have different part numbers than those, and that's this single one. This black one right here is that single one, and these three are those, so that I don't get them mixed up and put them in the wrong thing. There's something else I noticed, which is going to help you guys out. This says stuff like 7310 right here. The part number on here, on these Nishikon, ooh, they're Nishikons. I'm slightly distracted. These are really good if you have them on computer parts. B1713, that's a different part number. But what I'm looking for to match it up like I did with these is the actual capacitance value. So it's microfarad, that funny little U with the hanging tail means micro. And then this one's 10 microfarad. So this one says, you may not be able to see it, 1 microfarad. This one says 10 microfarad. The instructions say another way to identify the negative side of a capacitor like this is the shorter leg, but it's the same with LEDs. You're gonna cut them off, then you won't know. I'll tell you later how to identify LEDs when the legs are cut off. Oh, be careful here. These are 1, 2, 3 of the 10 UF, and this one over here by itself is 100 UF. So I'm gonna line this up like so, to where it matches that layout, and put it in so they match the diagram. Now if they don't stand up quite right after you solder the other side. You can straighten it out and point it up, but don't do it too much. You don't want to break it. Next is these 100 picofarad capacitors. And there's these little round ones, and they just say part number 101 on them for me. They're the only little round ones in here, and there's 2 of them, so it's them. When you get to the super tiny capacitors, they don't have values written on them. And look, on the board it says 100p. I bet Brits would immediately think that meant 100 pence.
Ooh, shots fired.
And these boxy style ones, you notice how the instructions have a picture of it from the side as well as from the end. On one side they just say 10 on them. On the other side they have nothing that indicates 10 NF. 0.001, where this one says 0.022. That says 22 NF. So 0.022, that's probably your 0.22 NF. In this bag, they all say 10 on one side, but on the other side they say 0.01. Which is that. It says 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. So that clears that up for me. I forgot to say this, but just like the little golden color ones, you can put them in, I can't talk. You can put them in either orientation, this way or that way. Just make sure it goes in the right spot. And this is 10N on the board. Oh, look at this. There's a spot where I accidentally got solder in that hole. I won't be able to get it in there. So you want to, if possible, put your soldering iron into the hole on one side. This is kind of awkward. I'm holding it against my chest, the soldering iron, with this going into the hole, and this is compressed. I'm going to put it up like this, and it didn't do it. So let's try it from the other side. Be super careful. Look where I'm putting my thumb so I don't burn myself. Do that a couple times. Good. Now I could see through the hole. And that's a 22 NF, so let's get this in there. Now it goes in. Spread the legs out a little bit. Now this resistor got pushed over this way too far. Let's just push it back a little bit. It says 22N, so I'm putting this in there. Spread out the legs a little bit. And I'll put it on here and solder it. Now 1 UF capacitor and 1 UF capacitor. What? See, it's showing a part number on the end. So let's see if I can see the difference. 1J63. Okay, these are the 1J63s. Those are those two. And then 1J63. What? Smaller? But they're the same? The same part number and the same capacitance, but one's chunkier than the other one? Could someone please explain me in the comments why this is happening? The lights were too bright when I was working on the pedal. I actually saw this in editing. The top one is 0.1 UF and the bottom one is 1 UF. 1 UF goes here and it says 100N. And these say 1U with no explanation. At least the part numbers and level of chunkiness match the diagram. Now it's the lead wire stuff. It's like 24 gauge, I think, just from guessing. Solid core wire is... Shut up, police! You're not in this scene! I have this measure tool, the Kyrich digital caliper by Kyrich. But anyways, what was I saying? Solid core wire is super awesome when you're building guitar pedals because of 2 reasons. The part of the wire that you expose won't fray and go all over the freaking place, and instead of going through the hole like a good wire, it's like 2 little tiny pieces go through the hole and the rest of it's like spreading all over. And then the second thing is that if you bend it in a certain shape, it stays there. Oh, quick note from me in the future. I thought the wire that came with the Stewmac kit was solid core because it was so good, but it wasn't. It's stranded. It stays in the shape you put it in, and it was really easy to work with. I do recommend grabbing some 24 gauge solid core wire as spare, because that way you know you got good quality. It does what you want it to do. This kit comes with blah blah blah, cut into 6 2-inch sections and 9 1-inch sections. All right, the Kyrich, save me now. This one, I'll put a link in the descriptables for you. And I might even be using this later if I modify the pedal enclosure so I know where to drill. But it has inches in fractions. Look at that craziness. Of course, this is centimeters and on here in inches. So put it down to the 1 inch. 1 and 3 1/28, 1 and 1/64, 1 and 1 1/28. 1 inch! And you could tighten it down if you wanted. But if it says a bunch of 2-inch sections and a bunch of 1-inch sections, it probably means a little bit less than that, but I'm gonna cut a little bit more just in case I'm wrong in that assumption. All right, there's a 1 inch. I need 9 of those. Germany Christmas. I just compare it to the other one. Man, could you imagine being a boutique guitar builder and you have to do this all day, every day?
I hate my job.
And do not do what I did because I don't have enough wire. I'm gonna have to figure something out. I have other wire. So don't cut them with extra like I did. You'll run out. Come here, extra wire. You're gonna help me out with this scene. And if you thought that was the annoying part that went on for days, this is why I told you guys you need one of these thingy whatsits, because this is a lot faster than scissors. The 2-inch sections will attach the in, out, and DC jacks at the top of the PCB, which is these, and the 1-inch sections will attach the breakout boards to each other, so this to that. And as you can see from this diagram, they're going in through the top in all of them. I'm putting this in here, come up from below. No one told me I was gonna have to be a freaking surgeon to build guitar pedals. It better be worth it. But probably will be worth it to have something that sounds like an Analogman King of Tone, but not have to spend as much money and build it myself and make whatever tone I want out of it and mod it myself. Now we got the wires coming out of the top, just like the picture, and then you could tell they flip it in this picture. This side down. Thank you, Stewmac. I've got 6 of the pots in here already in there, sort of. And what I'm doing, oh, that's what they're doing, is they have them bolted down on the top so you can measure and get this together. So let's do what they're talking about. Flip it over and be clumsy like me. Do it like you're doing it on purpose because it's going to happen anyway. But I noticed something. These have anti-rotation pins, which is this thingy, and we don't need them. How I know we don't need them is because they actually solder into the PCB like so, and the PCB is going to keep them from rotating. You need to keep these pins in guitar pedals where the pot does not solder directly to the PCB and it's loose and you don't want it to spin around, and you drill like this little hole next to the bigger hole. This is an A100K for the drive over here. But do double check these values before you bolt them in, because the case is going to be what holds the PCB in place when you solder the pots into place. That way when you take them out of this way and turn around and put them on the other way, they all line up with the case. Now look at that. Now I have to straighten up all these pins to get all 1, 2, 3, 4, 5, 6, 18 of them through the holes. And it says right here, for any pots that do not have a plastic cap, attach adhesive foam tape to the back of it. None of these have a plastic cap. At least they provide the stuff that you need. But they only provided 4. But I think I only need these 2. Well, I'm gonna at least do those 2. I've used these before. Just put it on like that. Toss. Like that. So I'm wiggling them back and forth and eyeballing it to see what's going on. And it's kind of working, but not really. All right, got those 4 started. So be super careful and slow, because I just screwed it up and bent one of the legs. Now you look at it on the side and you can make sure they're all in like that. And you can see why you have to put a point with my knife, the pad right there, so that this doesn't short these together and make like this capacitor touch those wires. All right, solder. Let's make this permanent. Of course, they had these 2 parts soldered together in their instructions before they did this part. So maybe you could do a better job than me and somehow already have this done. Oh well. I'm doing it wrong. Ow. Warm. This is actually not that bad. With this being held still, it's not that bad. You just have to hold the solder with your mouth. Oof. And not drop the soldering iron while you're talking with the solder in your mouth. Well, that's what that looks like, I guess. Now I'm going to flip these switches around. Just tightening it down with the washer first, and then put a nut on there and tighten it down. I don't know how necessary this was, but oh well, since there's two switches and they have to end up aligning with the holes in the case, I guess. Stay down! Need to take a lot of solder. Try not to block the camera with my head. Do one on the other side. Now it's kind of holding it. Oh, just magically just go, whew, and have solder all over all of these. Magic! Alright, that's enough from tonight. I'm doing step 14 later. Alright, it's day 3 for me. I've already spent a little under 3 hours on this, but I don't think you guys would spend as long because you're not trying to explain to a camera constantly what you're doing. You could just read and go. My guess how long it would take? Probably a third of the time, especially since you have my video to help you. I know when someone's helping me work on a project, it takes about a third of the time, and that's based on my own experience of working on things like computers or my car. If someone's there just to hand me a tool. Oh, here's that wrench that you set down. Now we want to figure out where the battery thingy what's-it goes. We want to free this of its temporary location on this. I did not tighten these all the way, just enough to hold it steady. So now I'm taking them all out. Right now, I'm just grabbing it with the pliers and turning it a tiny bit to make it loose so I can remove with my fingers. And I have my hair goop thing here and it's cleaned out, and I'm just going to put these bits in there instead of trying to keep them on here like I just started to, because I know I'm just going to have to take them off again, you know. I know the bigger ones are for the foot switches and the smaller ones are for the pots. Right here it says turn the component side of the board up. That means this way. And they say thread the 2 wires from the battery plug thingy through the tiny hole. And the tiny hole is right there. They've got it pictured like that, but it's not going to sit that way. It's probably going to sit more like that when you're trying to assemble it. Don't worry about it. It says put it under the back of the PCB and tack the ends to the back of the middle pot with a small piece of tape. The back of the middle pot. They got the second pot. I don't have a piece of tape. Wait, I do have tape. I've got tape for working on guitars that got water damaged in the flood. The great flood that flooded my basement. You can click a card right there if you want to see it. That video, I mean. This tape's so good that it still works even though it's flood damaged. Pull that down. And this is an item from Stewmac. If I can find it on Stewmac, I'll stick a link in the descriptables for you. Now this tape that's exposed is dry. And that's not because of the flood, that's just because I don't do setups on guitars that often. That's good. Now we're doing the LEDs. I don't know what color they are yet, but one's clear looking and one's red looking. You might be like, that one's white, Rob. Don't you know just from looking at it? Actually, the diffuser color has nothing to do with the chemical or material that's in there that is the LED color itself. This right here explains that the shorter leg of the LED is the negative side, but what if you clip them off? I'm going to show you another way to check which side's the negative. You notice right here, that's the shorter one. It's magnetized, dang it! Ah! All right, the shorter one is now on this side, but the element inside it actually has the, I don't know, mineral? Yeah, there's a good word. That illuminates is the bigger piece. And that bigger piece is connected to the negative side. This right here explains that the LED has a ring and a plug to go into. And it says start with the case in this orientation. And these are the bits that you want right here. There's actually a nut as well and a lock washer. And in this diagram, you have what they call later, the bezel goes on the outside of the case, and then the lock washer, and then the nut, and then the LED. Oh, and then the plastic bit goes on after? Oh, look at that. It does have two little holes in it. That's kind of cool, actually. Just like the picture, I'm putting it in this direction, because if you can see there, you've got that cap piece. Now I'm going to take these apart. These arrows point which holes to use. What? It's not going through. Am I doing something wrong? Yes, I'm doing something wrong. I did the wrong holes. Those holes. In my head, I was actually imagining drilling them out. That would have been bad. And then the lock washer on this side. Some nuts have a flat side and like a beveled or rounded side. These don't seem to have a difference. But yes, they do. This side kind of looks softer and rounded, and the flat side's that side. So I want to put the flat side down so that it makes more contact with the lock washer. 10mm socket seems to work on these, but the other end, all you can do is grab it. My fingers, ow! Well, it doesn't hurt that much. Oh, I got little rings. Oh well. I always come out of these kits with a few scars. As I said as a joke in a previous video. I got burned a couple times from my soldering iron, but not bad enough to have scars. They're not really scars, they heal. It says the positive LEDs of the LEDs go through the hole marked A, and the negative is marked K. Why can't you just have plus and minus on the board, Stewmac? I also noticed that on the board the K is a square hole. I think that plastic piece probably gives it just the right amount of length to reach. Move these out of the way for now. It says once the LED leads are through the PCB and the shafts of the pots and the foot switch are in their holes, reattach the washers and nuts for the last time. Promise. All right, looking at the instructions, A is positive, K is negative, and the K is a square one, and you have to flip it over. So shorter leg is the negative, go through the square one. If you put an LED in wrong, as soon as you add power to the board, it'll burn out the LED. I've done that with other circuits. So this one's got the negative on the other side, so the shorter leg goes on the right. And I put the red on the right and the clear looking one on the left because this is like that and it's going to get flipped. Now I presume I have to somehow magically line up 10 things, and 2 of them aren't even soldered in yet. You know what? Bend this so it's out of my way like that. Here's the problem though, is that you need the LEDs to be perfectly straight. So how about instead of fussing with myself about it, I'm going to bend these LED legs like that so I still have some freedom to move the LEDs as I put it in the case. You know, I don't move them that much, but they're going to shift slightly as I adjust things to put it together. And I'm leaving this foot switches out. Now you can't really see what I'm doing, but I grab these legs to move the red LED into the right spot. So push it down, flip it, inspect, make sure it's all together. You can see the LEDs peeking through. Looks like the clear one is coming through better than the red one. So I'm kind of just looking in here. The plastic sleeves go down into the metal things, is the trick when you have it lined up right. I can't really show you that. Can I? All right, maybe you can see. See how the plastic thing goes down inside of the metal thing? I think it's called a sleeve going into the bezel. And now when I flip it, you can see the LED poking through on both sides. And now get my hair goop thing back and put the washers and nuts all over my freaking, what are these things called? Come on, brain. Words is hard. Pots. The freaking pots. Sorry, all my mental energy was used at my actual job where I make money. So if you guys could... My freaking gimbal's blocking my cool shirt. Subscribe to the channel so someday that I get monetized, have a tiny bit of side income. That would be sweet. Now that's going to stay put while I solder in the LEDs. Can you see how I'm doing it? Can you see? So here's another tip. Make sure you have plenty of lighting. And overhead lighting is the best. If you can pull it off. Oh no! That's too much. So let's solder sucker it off. And see how I get the old solder out and just dump it on the floor so it crunches underfoot? Now I'm actually glad that I put the longer wires on this part because I'm able to pull this back and put it down. You guys might be able to do this without pushing that over there. Now I'm just putting the washers and nuts on the foot switches like the instructions say in step 16. I'm gonna try the 14mm like they said, and it does fit. Good. And that's done. It looks like a pedal. Please note the DC jack and input jack are different for models 12251 and 12255, so choose step 17 through 20 according to your model. Huh? This is the DC jack. I think this is the input jack because it looks stereo and this looks mono. Because on a cable that is stereo, hold on, I got one. It looks like this. But your guitar cable going into the pedal, get off of here, dust. You're not in this scene. Stereo cable, mono cable. I can't talk. Stereo cable, when it goes in, the tip, ring, and sleeve contact with different points on here. So there's a tip, there's the ring, and the sleeve gets this one. What happens when you plug your guitar cable in, it connects the ring to the sleeve, and that's what completes the circuit in the pedal, and that's why pedals turn off when you take the input cable out. Remove the nut and insert the DC jack into the top of the housing. Remove the nut. Stop going on crooked, nut. Go on straight. Quit being a crooked nut. Your threads are not crooked. The correct term is cross-threaded. So it is possible to thread it on, but it's a pain. So I'm going to flatten the nut against the case like this and spin around. It's the thing and it's still not crooked. There we go. Now it's going on straight good. And this says 14mm wrench. Oh, okay. Maybe. This says or needle nose pliers. That's what I usually use, but I hate tearing up the nut that way. Definitely one thing you don't want spinning around ever. So you put it a little snug. Don't do it too snug or you'll strip the thread on the plastic on the actual jack. This is a nice diagram. Battery, positive, and negative. And it says solder the battery clip red wire and positive and negative wires coming from the PCB. If we look at the PCB, there's your positive, your negative, and your battery red wire. And that's why the tape was there, so it wouldn't go disappear and make it difficult and stuff. I'm actually gonna loosen mine and turn it so that it matches the picture to make this easier. I'm actually gonna do the one on the bottom left, which is the positive coming from the circuit first, because I won't be able to get to it with the soldering iron if I put the one above it first. Pull some solder out like that, and I'm gonna go like that. And now, ow, 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 the wire's hot, ow, but I'm still holding it because I'm waiting for the solder to cool down and hold it in place. Now here's a problem. The tip of that wire is getting precariously close to the other one, and I don't necessarily want to cut it off. I'm just going to use my side cutters and kind of use them like pliers and bend it back and see how that does. Now I want battery plus for the next one above it, but then again, looking at it, I'm going to block the negative. And another pro tip is I could have put a black wire or a purple or something for that one to make it easier to identify in the future. I'm going to point this one down after I bend it. In my case, I can hold it against that pot. Now the battery plus can go on top. Now watch. See, that's poking up, and now I'm not liking it. because it's going to be poking it one way or the other. So I'm just going to go ahead and cut the end off. And turn this over and shake it. And I think it fell out. I hope it fell out. You don't want little bits of metal floating around inside your circuit. I wonder how people do this without putting the solder in their mouth. Alright, that's done. Oh my gosh. Sleeve tip lug, ring tip, ring lug. You're only soldering to the lugs. I haven't even read the instructions yet, but I know you're just soldering to the lugs. They want us to put the input jack on the left side of the housing, which makes sense because when you flip it over, it's going to be on the right. Go in there. There's not much room. You gotta move the wire out of the way in order to pull off this trick. And I'm actually putting these, I thought they were spare or not enough. It looks like I need them on these outer ones. I'm going to put it a little bit more towards that edge. Let's see if that helps me out here. Oh yeah. And he said put it in with the tip connection facing down. And this is the tip connection. And I kind of got the same idea when I was putting it in, so that this would sit like that, because I don't want this to turn and make contact with that. Stewmac, just give us more of these to put on there. That would have, you know, solve the problem. Add the washer and the nut. And when you tighten it, it wants to turn towards that pot. And that bit of foam I put on there is separating it. Gotta keep them separated. And you get points if you go in the comments and tell me what song that is from.
Points don't matter. Points don't matter. Points don't matter.
It says here the tip lug should be the one closest to the outside wall of the enclosure. Looking at the diagram, it's those three, and tip is on the left outside of the enclosure. You see the three lugs. Good. And it says solder the wire on the right side of the PCB to the sleeve lug. What? Using the in. That makes sense. This is the in jack and the tip is where the signal is. And since the audio signal is mono, the signal coming in is in and ground. I'm going to solder this right here and watch how I put it through. It's like this at an angle, and then I can hold it down and it's going to put force on it so it stays there while I grab the solder. See? You want enough so it just covers that whole hole, and you can't really see, but I can. When you flip it over, you don't see the hole from the other side either, that it's been filled in with solder, and that the solder's come through and is touching the wire on the other side. Focus! Show the people! Well, sorry, can't show this too much, but you just have to trust me. You can see the wire coming through a little bit. And then the ground, they have it going to the sleeve lug, which is the middle. You do the same thing. Hold it like that. Oh look, I might be able to do it like this, since I've got all this dexterity in my fingers from playing with Lincoln Logs and Legos and Erector set when I was growing up. Or was that when I was time traveling, because that stuff is before my age time? I don't know. Alright, Mr. Dexterity Hands. I think you're so clever. It's kind of okay, but let's get a little bit more. And then the ground from the battery goes to the ring lug. This is going to be hard for me to do at that angle. And you're going to probably have it at the same angle too. So how would we do this? I'm going to put it like this so you can see from camera 3. I'm going to show you a trick. Grab one of the leads you cut off from the components. Then use it to gather up some flux. You just need, you know, about the glob size of a small booger. There's a small booger. And you paint both sides of the lug that you want to solder onto with it. Then you get your soldering iron and you burn the flux. And that's going to start to oxidize the surface of the lug and remove some of the protective coating, which solder has flux in it already and would do this anyway, but you're prepping it. And you'll notice how it starts to burn, and you want to do the back side a little bit, and then get some solder, just a tiny bit, put it on the tip of your soldering iron, and go like this around the outside, so you have a shiny ring, and then put this through, heat up that solder that you already put on it until it all melts, and it's going to grab that wire for you and hold it for a second. Then finally, if you can with your superhuman dexterity skills, hold all the things and block camera 3 while doing it, but maybe camera 2 can see most of what's going on. Get the actual solder that's going to hold it on started. Ow, solder got hot in my fingers. Let's do it this way. No, go back in there. I drooled all over my instructions. No. Ew. All right, I cut out the part with the output jack to save time, and just because I can explain what happened, and based off of how you saw me do the input jack, it's real simple to understand. The lugs would not oxidize very easily, so I put flux on them the same way as the input jacks, except that I had to hold the soldering iron on each side of each lug for about 2.5 minutes until it started to turn brown, and then when I went to put solder on it, it would stay. Otherwise the solder would just keep wicking off and going back onto the soldering iron. But make sure you have the hole in the lugs where you put the wire through completely filled with solder on both sides, and that's going to prevent something called a cold solder joint when things cut in and out. Cold solder joint prevented. And what that is that it'll work for a while and then start cutting in and out. If you've ever had a cheap guitar where the input jack cut in and out, it's because they didn't take the time to do what I just did. And you can take yours apart and probably fix it by doing that. And you may notice I've got these wires oriented so that when you put the cable in, it doesn't push on these wires and rip them or anything. That's what it should look like, guys. I'm gonna get this soldering iron and turn it off like that. Like that. Put it in your brass pad, scrub it. So now it's all shiny like that. Put a little bit of solder on the tip. Run it around like so. And turn it off. Analogman factory setting. Switch 1 is on. Okay. Clean boost is all off. Overdrive 1 and or 3 is on. Huh? Distortion is 2 and or 4 on. What? I'm a little confused. So I'm just going to read these instructions, make it make sense in my head, and then tell you what the frick is going on. Alright, the right side of the foot switch uses switches 1 and 2. The left side uses 3 and 4. You know what? I'm still not understanding their instructions. So I'm going to hook it up to my guitar, see what we can figure out. Oh, I didn't do the knobs yet. Genius. Turn all the knobs down to the bottom, which is 7 o'clock position. And you get these, and I need a tiny screwdriver, which I need my iFixit kit. Hold on, I gets it. iFixit kit, also linked in the description. What's it's below. You have to loosen these little set screws. Like so. Loosen the screw until it starts to stick its little head out. Point that down to 7 o'clock, which is actually like 7.5, I think. Somewhere between 7 and 8, but you know, point down at that angle so that when you max it out, it's over there. And 12 o'clock is actually 12 o'clock. And you know, obviously, before you spin it around like I just did, tighten it. Hold on while I put all those on there. All right, I figured it out, and here it is all assembled and everything. So according to this explanation, the right side of the switch, which is this side, is controlled by the left switches. And the factory position only has switch number 1 turned on. So that means this side should be overdrive and this side should be boost. So listening with just the compressor on by itself, very quiet, but turn on the overdrive side. How much going on there, and that's even cranked. Put that over there at, let's say, 2 o'clock. You hear a little bit of drive. Turn this back down because I'm about to do something else. Let's add overdrive to it. Turn this down, turn this down. Or boost, I'm sorry, this side's boost. Duh, just boost. Just overdrive. Add boost. Oh, that's super loud, we don't want that. Now, if we flip this over, and by the way, I got plastic here, so it doesn't get shorted out like on these metal globs of solder that spilled. Do 1 and 3 so they're both overdrive. Now here's the more vintage circuit that I made. It's not much there. Volume drive, so let's turn the volume to 12 o'clock so you can hear it better. The more modern one. But turn the volume back a little bit on them so I don't clip the mic that I have in front of the amp. You can hear the difference between these two because I put the more vintage stuff on this side. But if you did it like the factory way that this comes, it would be different. Both sides would sound exactly the same. Now let's try the distortion setting, which is 3 and 4. So let's just try it like this. I'll turn it up, 12 o'clock for this test. Modern side. Put them together and turn it down a little bit. Now here's the thing. What if you turn them all on? Now you've got overdrive and distortion going on at the same time. Just the vintage side. Turn that up. Modern side. Let's put them together. Let's add some fuzz to that. Pretty cool. You can definitely mess around and get some unique tones out of this, especially with the modifying I did. Like for example, I could probably get this side a little bit louder by changing those ceramic resistors back to the metal film ones. Or just turn up the volume on that side. What I need you guys to do, if you haven't yet, like and subscribe, obviously, and tell me in the comments is the thing I'm really looking forward to seeing. What kind of tone comparisons that I should do in a follow-up video. I don't know any famous songs or licks, but I've got a few of my songs. I could try different things on the guitar maybe. That's what I want to hear about. If you enjoyed this video, you'll love this one where I built a buzz pedal that uses op amps, and I tried different op amps to see what kind of different tones I would get. And click here for whatever the YouTube algorithm thinks is best for you. And you can subscribe to my channel right over here. Thanks. I'll be seeing you guys in the comments.